looking at exponential functions and look at the differences between growth and decay when we're looking at the equations. So remember, when we're dealing with growth, the number in the parentheses is greater than 1 because it's growing. It's multiplying by something bigger than 1. It's getting bigger. For decay, that number inside the parentheses is less than 1. So it's multiplying by maybe a half or a third or 3/4. But either way, it's making it smaller. So let's start by just deciding if these are growth or decay. And then to find that rate of change, remember it's how far away it is from R, or from 1. So if it's bigger than 1, we've got growth, smaller than 1, decay, and we just see what that difference is. So this first one, we have 1.09. That is bigger than 1, so it's definitely growth. How much bigger than 1 is it? Well, it's that 0.09. So R is 0.09, which is 9%, because they want it as the percent. Okay, the second one, if we look at what's in the parentheses, that number is smaller than 1, so we have decay. How much smaller than 1? Well, you might be able to look at it and know that it's 0.7. Otherwise, you can always just do some scratch work and say 1 minus 0.93, which would give you 0.07. So the rate as a percent is 7%. Okay, why don't you try the next two and then come back and see if you've done them correctly. Okay, for the first one, that number is smaller than 1, so it is decay. How much smaller? Well, 0.08, which is 8%. And for the last one, we have something greater than 1, so it is growth. How much greater? Well, 0.2. And 0.2 is 20%. Remember, it's not 2%, it is 20%. We have to move that decimal twice. Now, sometimes we need to rewrite them to decide if it is growth or decay. And in order to do that, what we want is to just have an x, or in this case a t, as our variable. So we have to use our properties of exponents kind of backwards to rewrite it and do all the calculations we possibly can until we just have a number to a variable. So when we look at the exponent for the first one, the exponent is t over 2. Remember, that's the same thing as saying 1/2 times t. Okay, that's just another way of writing it. And we want to have the t by itself. Well, with our properties of exponent, which kind of setup would we have if we ended up having to multiply the exponents? Well, that's the power to a power. So we're going to rewrite this. We'll leave our y, we'll leave our 20, and then we're going to say 0.81 to the 1/2 power. We'll do this in a different color. And then that whole thing to the t. Because if I take 1/2 times t, I get my t over 2. So we're just undoing that property because we can calculate 0.81 to the 1/2. Remember, a 1/2 power is just a square root. So we're going to have to do the square root of 0.81 to the t. And you can do the square root of 0.81 in your calculator. If you do that, the square root of 0.81 is 0.9. So we've rewritten it so that it looks like y equals a times b to the x. Only have that variable in the exponent, no extra stuff. And now we can look at what's in the parentheses. What's in the parentheses is 0.9, so that tells us it is decay. And the original problem looked like decay because we had a 0.81, but we can see that the decay rate is actually a little bit different. Okay, so let's look at this second one. If we look at the exponent, t minus 2, what property do we use if we end up subtracting the exponents? Well, that means we're dividing. So we need to rewrite this so it looks like division. And the one that comes first goes on top of the fraction, and the one that comes second goes on the bottom. So we're looking at f of t equals 2.5 to the t over 2.5 squared. We're undoing that property. So we can calculate 2.5 squared and leave our 2.5 to the t on top. 2.5 squared is 6.25. Okay? Now, it doesn't quite look like a times b to the x yet. But remember, dividing by something is just like multiplying by a fraction. So we could rewrite it, f of t equals 1 over 6.25. So basically, I took the number part, moved it to the front, and then that leaves me with the times 2.5 to the t. So here's my a. It's a funky number, that's okay. Here's my b, and there's like my x. So it fits our format. Since our b is 2.5, that's definitely bigger than 1. So it is still rho. So all we're doing is undoing properties of exponents and then calculating anything we possibly can and making it look like y equals a times b to the x. Okay, so for this one, our exponent is 10t. Remember, we could say that's 10 times t, so we're going to have power to a power. So f of t is equal to 3. And then we've got 1.02 to the 10th, and all of that is to the t. So you always want to take your variable and make it be the outside one, because then we can calculate the 1.02 times 10 to the t, or times 10, to the 10. 1.02 to the 10 is a really long decimal. I'm going to put a whole bunch of decimals down. And then we still have it to the t. So there it is. Y equals a b to the x. Our b, bigger than 1, which means it is rho. Okay, so this last one, our exponent is t plus 2. In which situation do we add the exponents? Well, that's when we're multiplying. Subtracting was division, adding is multiplying, and multiplying is exponents. So let's write it that way. Y equals 0.95 to the t times 0.95 squared. We're undoing that property. Okay, so now we can calculate this part, and that becomes our a because it's just a constant. It's just a number. 0.95 squared is 0.9025, and then we still have 0.95 to the t. Looking at what's inside our parentheses, it's less than 1, so we know we have decay. This is just going to be one of those things where you're going to have to keep practicing and practicing because it goes back to the properties of exponents, and now we have to use them backwards.